And I'm going to, okay. So as said, right, we have come towards the end. Okay, we have seen a couple of slides. We have seen how to present. Now, what I want you to is practice. Okay, I want you to practice different things. Okay, so this is one good project. Okay, from Python perspective, of course, we'll do similar projects in Tableau, Power BI as well. But understand this. Okay, so here, okay, this is about creating pivot chart, Pareto analysis, scatter plot. Okay, so here we have a data about baseball game. Okay, and this data has baseball game record since 1800 or something. Okay, so we're taking all this data. So these are the columns. Okay, date of the game, visiting team name, visiting team league, etc. So see, when you get your resume built, okay, when when you see the job description, okay, try to link it to these projects. Okay, try to link it. When I say link it, it means that see, see, they're not going to, they'll, of course, they'll ask you, okay, what is pandas, how joins are done, things like that. But those are easy questions. You prepare, you get it. But the project related information, it is very difficult to say if you have not worked on it. Okay. And believe me, the way you answer, okay, will tell enough if you have practiced or not. So these questions, okay, the question will be, what have you done? Simple question, what have you done? Gone. The way you answer, the person will know whether you have done it or not. Simple question. See, if it is straightforward technical question, whatever subject, more or less you'll be able to answer. Okay, correct or wrong, you'll be able to answer. You'll have something to answer. And as an interviewer, it's difficult for me to reject even if you answer 50%. Because yes, we work day in day out, we work on 100 different things. So it doesn't, it's okay if you don't remember anything. I mean, if you zero on everything, then it's problem, right? But even if you are 50% correct on technical stuff, it is okay, because they know that, okay, you know the answer, because we do more practical, right? And sometimes theory you may not know, so it's okay. And you don't remember the code as well, right? Nobody remembers code. Okay, very difficult to remember code. Okay, so you need documentation and things like that. Okay, so that's understandable. But question like what you have done, that you should be able to tell, isn't it? It's not technical. There's no technical question in it. Okay, what kind of data set you used, what kind of analysis you performed, why did you perform those analysis, who used it, who told you to present the make those slides, or make those um, image plots. Okay, what I find is most people doesn't even know what the project is about. You write a project, oh, this project is about managing retail store, online business or retail store. Okay, fine, we're online. So what metric did you use? Oh, we used all the metric that is required to manage online store. Can you give me specific examples? Yes, something like sales and products, and okay, that shows that you have not done it. Okay, if you say that we looked at sales, daily sales, we looked at daily sales per category, you know, it even though you may not have done it, it gives more confidence. Okay, so sales, inventory, these are high level stuff. Okay, what exactly did you do with sales? Okay, so daily sales, we looked at daily sales, we looked at weekday versus weekend sales, we looked at um, um, inventory or sales per inventory. Okay, we looked at sales per category. Okay, and we classified the product based on sales per day. Now these are okay, these looks like okay, there's something you have done. So always, before you perform any analysis, always you start with what we call as business case. Always have business case in your mind. Okay, so business case. Okay, and if you have business case clear, business case means why you perform certain thing, why did they hire you, what was the role of your team, what was the role of you, right? Then everything will get clear. Everything will get clear. Okay. So now here, if you see, okay, I'm talking about baseball data. Now, as a business case here, I'm going to show you the next slide. Okay. This talks about the games that were played. See, it has data from 1817 to 1920. Okay. These are number of games that were played on every day. So blue is Friday, orange is Saturday, Sunday is green. No, Saturday is green, Monday is orange. Sorry. Now you tell me, most of the games were played on which day? Or which day had the least games?
That's on. The more games are on Thursday.
Thursday? Thursday is brown in color. What about green? Don't you think green looks bigger than the
Uh,
brown one?
Yeah, the area of green is
yeah,
bigger.
yeah, that's true.
Right? So it looks like,
And Thursday
most
is
of
purple color.
what is purple? Thursday is purple.
Thursday.
Yes, yes, sorry. Yeah,
Mm.
Thursday is Tuesday is brown. Correct. So, probably
Okay.
green looks bigger than purple, right? If you see the width. Okay. So that means most games were probably played on Saturday. I mean, if our visualization is correct, right? If really the area of green is bigger than the purple, then yes, the most games were played on Saturday. Which day had the least number of games?
It's on Sunday.
Sunday. And if you
Sunday.
see, traditionally very few games were played on Sundays, and it's only later part of 1900 that most games were started being played on Sundays. If you see, 1870, 1880, even up to 1900, okay, or maybe 1890, very few games, almost negligible amount compared to others. And then 1920, you see, it had maximum number of games that were played on Sunday. Was in 1920, right? The area in 1920 is bigger. Okay, so this is the objective. You want to see, okay, which day people generally played most of the baseballs. So which day had more baseball games, right? So it looks like, okay, this data will give you. Now you have let's see this. Okay, actually there's one Pareto analysis. What is Pareto analysis? Okay, Pareto analysis tells you in terms of percentage. We say that, right? 20% of people perform 80% of the work. Generally, this is the rule in life. Okay, the rule in life says that 80% of the work income, let's say company, right? 80% of company, 80% of the people, they do 20% of the work, and 20% of the people do 80% of the work. Okay, so most you can fit this. This is called Pareto rule, 80-20 rule. Okay, or Pareto rule. You can fit it in almost all the situation. So we want to see, okay, for a online business. This data is from online business, and okay, this is data analysis, basic data analysis, how many product categories, things like that. And then you see here, okay, uh, so this is product categories based on demand. Okay, so see, bed, bath, and table has the highest sales. This data is of a Brazilian e-commerce company. Okay, so if you see this data, looks like bed, bath, and table has the maximum sales in the category. Then you have health and beauty, sports and leisure. These are the categories that have maximum number of demand, or and here it's not a dollar value, it's count. You see number of orders that they got. Okay, it's the number of orders we're looking at, not the value of the sale. So which is more popular? If you talk about more popular means the product that are more liked by the people, not the value, right? So that's what. So your analysis should be alignment with your objective. Okay, so if your objective is to find the most popular product, so popular product means the count, right? Number of number of people that were interested to buy the product, not the dollar value, right? I mean, a product could be $1 million one product, but doesn't make it popular. Okay, Popular is even value is less, but people want to buy that. So this is the count. So that's why we talk about popularity. It is the count versus the thing. Okay. So he says that bed, bath, and table is very popular. A lot of people bought it. And if you go towards the end, you see security and services, fashion, children clothing are very few. Right? So top 5 popular categories are bed, bath, table, health, beauty, sports, leisure, furniture, decor, and computers and accessories. These are your top 5. Right? So this is how you will create this graph. So now in the data, okay, you will not have number of you will not have this data in one single table. You have to summarize the data. So what you will have, the sales data. Okay, and when we talk about sales data, what you'll have is you'll have say order 1, okay, customer 1, product, okay, and category, right? So you have product and category. Okay, so now what you have to do is you have to add all the products. There will be multiple products in the category, so you have to add all the products, okay, by category, and then you will summarize the data saying, okay, this category had 100 products, and this 100 products totally sold for 10,000. So then you'll put 10,000 here for bed bath. So bed bath is a category, not a product, right? Not a specific product. So in this category, there could be 100 products, and each 100 products selling 100 copies of each, or 100 pieces of this. So you got 10,000 as a number, right? So, so you will have to perform. Now you don't expect that, they'll take the data and just plot the graph. You have to clean data, take it, summarize it, and then you perform. That's where your NumPy and Pandas will be helpful. Now this is called your product categories based on sales Pareto chart. Okay. First one we had popularity. So we just created the count. Here you have the dollar value. Okay. How much contribution they made. Now see, though the number of product bed bath was highest, but in terms of dollar, you see health and beauty is highest, and bed bath went to 3rd position. That means the average price of bed bath products are cheaper, okay, less compared to your health and beauty. Health and beauty, the cost is comparatively expensive, more than bed bath. Okay, so that's why it became highest selling categories. So Pareto chart says 80-20. That means 20% of your product, 20% of your product will contribute to 80% of your sales. Okay, 20% of your product will contribute to 80% of your sales. So what you do is, on the bar graph that you see, we are plotting bar graphs with each categories with the number of sales. Okay, so you have health and beauty, which is about 3 million sales. Okay, then watch is about 2.9, whatever, right? You created this. Now you take the total of total sale made. So total sales, okay, probably would have been, let's say, 30 million. Okay, I'm just giving a number, I don't know. Okay, just let's say 30 million total. If you add all of them together, 30 million. So this orange dot shows the percentage. Okay, so if you say 30 million, then what is the contribution of health and beauty? 3 by 30, 10%. Right? Is it 10%? No. See, 100% is 10 million. Oh no, sorry, 30 million, right? We said 30%, 10% is 3 million. Yes. So contribution of health and beauty would be 10%. Now you do cumulative sum. Okay. So first you put it in a decreasing order. Okay. You have the highest, second highest, third highest, fourth highest, and the last will be the last highest. Then you start do the cumulative sum. Cumulative sum means 1. Okay. Then 1 plus 2. Then 1 plus 2 plus 3. 1 plus 2 plus 3 plus 4. 1 plus 2 plus 3 plus 4 plus 5. You're adding all those numbers. So you see here in this data, it says health and beauty is about 10%, right? If you add health and watches together, it comes to almost like 20%, okay, 30%, so on, and finally it goes to 100%. Now, if I have to take, if I have to understand the contribution, okay, I'll take a print screen of this, and let's say I go to paint, okay. Okay, so I want to know 80%. So what I'll do is I will draw a line from here, right? Straight line. Okay, this is straight line. Yes, this is straight line. So this is where this line touch 80%. Now you draw a line from here. Okay, so these are the products. These are product categories. Okay, that contributed to 80% of your sales. Okay, so you see how many product categories are there here? Maybe let's say 15. So 15 you have it, and 15 out of how many? Okay, 15 out of, let's say, 15 out of how many you see? Maybe 70. So 15 out of 70 is what percentage? 1 by 5, right? Almost like 20%, correct? So you see, 20% of the product are selling your 80% of the revenue, isn't it? So that's how, that's called Pareto, 80-20. Yes.
Yes.
Okay. So this is how you draw. Just give me a second. Give me a second. Hey, really sorry. I got one important call, so from family. Okay. So this is how you look at your Pareto chart basically. So in one single slide, one single graph, I know which is my top contributing categories and also the percentage of contribution to the overall business, right? So bed bath or health beauty in this case is contributing about $3 million, and that is about 10% of my business, right? Let's go back to the page. Okay. So I want you to do this. Okay, I want you to. I have the code. I'll be sharing this link. You have the code and you do it. Okay, and ask me. You can try today. Okay, I want to finish off Python today so that tomorrow we can start with something new. Okay, so this is product category based on sales. This looks same, right? Okay, so this is okay. There is one something called as others. So this is other category, which is not part of your this data. Okay, so it's same thing. Now, okay. So now you see, this is delivery days. Okay. That means when you order a product, or let's say Amazon.com, right? That's the company is very much like Amazon only. So when you order product on Amazon, right? When you order something on Amazon, the number of days that it takes to deliver your product. Okay. Number of days it takes to deliver your product. Okay. So you see that some product getting delivered within a day. Some takes 2 days, 3 days, 4 days, 5 days. Bulk of the products takes around 6 to 7 to 8 days, right? And then you have some products coming after 30 days also. Probably those are outliers, obviously, right? You don't expect 30 days for product to deliver, but there could be some situation where because of some whatever happened, some situation, product would have arrived very late. Okay. Now, what do you understand from this graph? What does this tell you? First of all, you are drawing what kind of graph it is?
Bar graph.
Bar graph, but what? What type of bar graph it is?
It's
I
a
didn't understand the
histogram.
question.
What type of graph it is?
Histogram?
It is histogram. Yes.
Yeah.
Okay. How do you know it's histogram?
The graphical presentation.
You see there's a frequency on the left side. Okay.
Oh, yeah, yeah.
Frequency
Okay.
will tell you it is a histogram. Okay. In histogram, we will look at, we draw the frequency. Okay. Number of, count of. So you see almost like 1500 products were delivered within day. About 3000 were delivered within second day. About 4000 were delivered on third day. Okay. Now what is mean, median, mode in this case? Okay. What is mean, median, mode in this case?
Mode 7,
Mode 7. Perfect. Great.
median 15.
Median 15. How do you know it's 15?
No. Median.
No idea?
Mm, mm, mm.
Median is 6 and 8.
Median is 6 and 8. No.
Median is not 15, Swapnil.
Median is 15? No.
It is arranged in the ascending order and the middle value is 15.
Okay. So what is this middle value?
The median.
When you say middle value, what does the middle value mean?
That's what the median, right? No.
No. Let's see who can help you to do find median.
So for median, 50% of values should be,
Correct.
yeah, above that value and below that value.
Yes. Come on, faster. So what did I say in median? Median is mid value, right? Mid value of what? Mid value of all the numbers. Correct or not? So here
Yes.
you will have 1,1,1,1,1,1,1,1,1,1,500 ones. Then 3,000 twos. Then 4,000 threes, 5,000 fours, 6,000 fives, 7,000 eights, or seven, whatever, right? Six, 8,008, so on. Did you understand what I'm saying? Let's take out pen and paper. Okay. Forget about this being 1,000. Assume that these are 1, 2, 3, 4 only.
Hmm.
Then do it and tell me. So I'm going to move this to paint, and then let me share the paint. So you have 15, right? So let's say 1.5 times. So you'll have, let's say 1, 1, 3 times 2s, 2, 2, 2. Then 5 times 4, 1, 2, 3, 4, 4. 6 times 5, right? So 5, 5, 5, 5, 5. Okay. Then 6 will be 7 times.
So, Swapnil, will 7 be the median? Because it's the highest number.
What did I tell you? I told you to do like this and calculate and tell me, no? Are you doing it? Please calculate and tell me. 6 is, yeah, then 3 plus 3 plus 7, 8. Then, no, sorry, 7, 6 times. 6 is 7 times. So 3, 7 times. 7 is 8 times. 1, 2, 3, 4, 5, 6, 7. Then 8 is 7 times. 8, 8, 8, 8, 8, 8, 8. The 9 is 6 times. Ten is 6 times. So 10, 10, 10, 10, 10. 11 is 5 times. 12 is 4 times. 13 is 4 times. So on. Do it till 30 and then you tell me. Five. 8.5. 14, 20, 27, 35, 42, 48, 58, 54, 59, 63, 67, 67, 70, 73, 76, 79, 80, 82, 84, 86, 88, 89, 90, 91, 92, 93, 94, 95, 96. Did you do it? So we have 96,000 numbers here, approximately. 96,000 or maybe 97, 98,000 approximately. When you have 96,000, what is the mid value of 96,000? 48, 49. Where is 48, 49? Between here. So your median is probably 9 or 10. How do you know by without calculating this? It's not that you, if you have only one value of one value of two, one value of three, then you can say 14, 15. Okay. Second thing, we told you this is a positively skewed graph. Positively skewed graph means median
Graph
will
is
be
going
on,
towards the positive axis.
yes, your median will be on right side of mode. Your median will be on the right side of mode. So obviously
Okay.
median will be on this side of 35. It cannot be on the left side. Ruled out.
Okay.
And your average is further away. Median is closer to mode. So median could be 8, 9 or 10. It definitely cannot be 14, 15. Yes, 15 can be maybe average. Mean can be 15. That's possible. Okay. But definitely median has to be closer. Median is always closer to mode. Okay, mean is further away. So mean can be 15 or 16. That's fine. But more obviously easy. So yes, you got it right, 7. But median will be either 8, 9, or 10, probably around 9. Okay, without doing this only, you should be able to tell. And your mean will be much away. If this is 2 bars away, this has to be like 5, 6 bars away. Somewhere here, 13, 14, 15, 16, somewhere out of these will be the mean. Okay, so what does that mean? Not mathematics mean, but English mean. What does this graph mean? It means, okay, most of the values are delivered within 9 days. 50% of the values are delivered within 9 days, but other 50% takes 9 to 30 days to deliver. Okay, if you had delivered within 18 days, the graph would have looked normal because 8 is your median. So, or 9 is your median, 9 on the left side, 9 on right side would make it normal, right? So if you had normal graph, then you would have said that, it makes sense to do that. Definitely. Okay, the graph is not normal. Okay, so most of the customers probably are happy, but there are definitely some customers who are not happy. So somebody who gets after 30 days. Okay, now again, this is delivery days. Does not mean that how many delay, what was the delay, right? If you have promised 30 days and delivered in 30, let's say you are sourcing from some other country, China, possible, it can take 30 days to deliver. So if you are saying 30 days and delivering 30 days, that's fine. But if you're saying 5 days and delivering 30 days, that's when customer is going to be angry. Okay. So let's go back to our. Any question on there? Okay. So this is about retail analysis. Now we'll talk about NLP analysis. Okay. NLP analysis, the retail data, but here we are looking at number of ratings that they have been given. Okay. So when you look at number of ratings, okay, so now we are looking at the feedback. So project work will not have one, it will be multiple, things together. So it's the same company. You evaluated their sales, you evaluated their delivery days. Now we are evaluating the feedback. Okay. So if you see here, 60,000 feedback are about 5, rating 5. Okay. 4 is about 20,000. 1 is about 12,000, 2 and 3. Okay. If I want to calculate the number of positive ratings, okay, I can simply take, maybe let's say 4 and 5 are considered positive. So I'll add them and divide by total. So that will give me the total positive rating. Okay. This is review created date compared to the purchase date. Okay. Now here you see you have dots. This dot indicates different color, indicates different review score. Okay. So you can look at, this is a scatter plot. This is a scatter plot. Okay. So you have purchase date here and the date, number of days from purchase date when the review was created. So it's a scatter plot, but scatter plot also has its phases, right? One indicates rating 1, then rating 2, and so on. Okay. So what do you see? What do you notice from here? What do we notice?
There are more 5 review score.
For that, we don't need scatter plot, right? We already know from the previous graph. If you see this, okay, let me draw something like this here. Now tell me, what do you notice?
So from 0 to 25
A
days,
drop.
the reviews are 5. After 25 days, the reviews are bad. People who
Correct.
use,
Correct. People who review,
okay,
gives review in initial
mm,
few days, okay, are
giving
give
good reviews.
good reviews. So generally people who, initially, okay, if they give review, they're giving you positive reviews. Okay. And after, after few days, let's say after 25 days, okay, bulk of the reviews are negative, right? So we see that people who tend to give reviews faster, they tend to give positive reviews. So these are people probably they like to give reviews. Okay, these blue people are probably right. We have limited data. We are trying to make assumptions. So probably these people are they love to give reviews. But these people, they don't love to give reviews, but maybe the product has stopped working. They're not getting their actual benefit. So they became angry and they came back to give rating because they're angry. Correct? Probably, right? Because why will you come after 50 days to give a rating? Correct? You give rating within 1 week, 10 days, 15 days. After 50 days, 60 days are coming back and giving rating, 40 days are coming back and giving rating. And your red means you are unhappy, right? You got angry and so you said, okay, let me go and give rating bad. Okay. But these are the people who generally they love to give ratings, right? So if you are a seller, you want people to give you rating faster or later.
Faster days.
Yeah.
Faster.
So, yeah. Request them to give reviews as soon as possible because sooner you get, okay. See here you see some bulk red, but most of this here is all blue, blue, blue. And here if you see it's all red, 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 right? Yes. So what I'm trying to say is just look at the graph. More graph you see, more ideas you will get and more you will be able to talk about. Okay. And these are the graphs that you need to also start using in your discussion, right? So see, I'm more thinking from the interview perspective. Okay, interview, project, one single project, multiple graphs, each graph talking about something. You have to go with a planned mindset that this is the company I'm working for, this is the data, this kind of work I do, and then based on your question, you should be able to respond to them. Okay, so there is this graph. Okay, so it's number of reviews, purchase month. So 16th October, 2016 October to 18 July, right? So you have almost like 2 years data here. This is the average review score. Okay, so this is the average review score for every month, and this is the overall average score. Orange one is overall average score. Now, what do you get from here? So review group by month. Okay, so what do you understand from here? So it means you see,
2000,
yeah, go ahead.
so 2017, October to 2000, I mean, mid, mid 2018, the graph is high.
Mid
I
18.
mean, not mid 18, it's the October to ending of 2017.
Ending. So 70, yeah. So yes. So not even ending. If you see here also, you initially when the business started, probably, let's say assuming that this started here or the data that we have in 16, your reviews were very poor. You got very bad reviews. After 3-4 months, you started doing something which helped you to get more reviews, right? And now they are doing extremely good. About 4.5 is considered very good, right? More than anything, more than 4 is good. So
Yes.
they were doing less business also. See, less business and rating was poor also, right? Then they did something good. Sometimes it happens that we want to give, we want to provide cheap, and then you say cheap and you start, and then there's a problem with the customer service. See, cheap means what? You can't hire more people to respond to customer service, right? We are getting less money. You can't spend more. So probably because of those things, you are not able to get your rating properly. Okay, proper, not good rating means service, right? Mostly it's a service, right? Even let's say if there's a delay, and if you inform the customer, talk to them nicely, tell them that product is delayed, do you want me to cancel it, do you want to wait for it, we'll give you a refund. So sometimes, even though the product is bad, you are making your customer comfortable, and then customer will not get as angry as someone who will give you rating 1. They'll be angry, but probably at least you can stop them from going and giving you rating 1, right? So you can do that, but probably you were not bothered, you did not pay attention to the customer service, and customers were, they were trying to reach you, they can't reach, so they'll give you rating 1, right? So now they probably did something in 2017 that actually helped them to improve their monthly review score. Now it stands above 4.5, which is really good. Okay.
Yes.
Yes, I'm going to share this code. Okay, you try this code, and I'll also share a Google Drive. I want you to submit the code, okay, of entire thing what I'm sharing today. So if not by tomorrow, by Sunday, I want the entire code to be here. And it's for those who are listening on recording also, not only those in the session, okay, the recording. So we'll stop here, okay. Tomorrow we'll take up new topic, okay. Let me think, we can take warehousing or W. Okay, we'll start building our project. Okay, so I complete my,
Swapnil,
yes.
so how do we differentiate between the bar graph and the histogram?
Both they look same. Okay,
Yes.
what do you put on x-axis and what do you put on y-axis? Give me an example of bar graph, then we'll talk about it. Give me an example of bar graph.
Uh, example means I don't know.
Where can you draw a bar graph? Production of apple, right?
Okay.
So apple, banana, mango, cherries. So production will be, so x, y, sorry, apple, banana will be on x-axis, right? So apple bar, you see, okay, 12,000, cherry 15,000 or 18,000. So you see, each of the things on your x-axis are different, right? It could be different fruit, it could be different month, different cities. We did GST example, if you remember. Okay, so we had
Yes.
GST, different cities, right? So different cities, different fruit. So though all them are related, like it's all cities, it's all fruit, it's all month, it's all quarter, but they are different. Okay, and then your Y will talk about absolute number, right? How much sale you made. Okay, if it is about sales, it will be dollar. If it is about quantity, it will be kg, let's say, or quintal, things like that. In your histogram, on x-axis, it will be same continuous values. Like days, it is 1, 2, 3, 4. It could be discrete or continuous. but on your y-axis it is always frequency. Frequency means we
Okay.
calculate, okay, how many, we had 10,000 deliveries. Out of 10,000, how many deliveries were made on day one? Okay, so 100. So
Okay.
100 is a frequency. So on y-axis it is always frequency. Frequency means count, how many, frequency. If you see frequency on y-axis, it is histogram.
Histogram. Okay.
Okay, bar graph will have anything except frequency, anything, count, kilo, number of
Okay.
days, or production, dollar, okay, whatever. Okay,
Okay.
other than frequency, anything you see, and each of these will be different, apple, banana, okay, but here delivery days, it's same delivery, continuous, okay, values.
Okay.
So if it is continuous values like temperature, you will have a curve
Bar
line.
graph.
No, continuous values will have a continuous curve. If it is discrete values like 1, 2, 5, like this, what you saw today, you'll have bar graph. Bar graph means discrete. Line graph
Okay.
means, line graph histogram is for continuous values, where you cannot draw a bar graph. Okay. So for telephone, remember the telephone example that we did? Telephone bills, that was a line graph. Okay. So line graph, it can be line graph also, it can be bar graph also. Okay. If it is line graph, it means they are continuous values. If it is bar graph, that means they are discrete values. Frequency on y-axis means it is a histogram.
Okay.
Okay. Okay. So I'm going to share this link. I'm also going to share the Google Drive. I want all of you to submit this project. And once you submit, I will share the details to the team. Okay. And tomorrow we'll take up something new, something different. So Python is done. Okay. It took a long time, but hopefully, with practice, you should be able to do it well. Fine.
Yes,
Made it
Swapnil.
here?
Yeah.
Okay. So take care, everyone. We'll see you tomorrow with something new.
Yeah. Swapnil, can
Yes.
you, if you don't mind, can you start Tableau tomorrow?
Oh, sorry, wait. Okay, we'll start Tableau tomorrow.
Oh, thank you. Thank you,
Sure,
Swapnil.
sure.
Thank you.
Thank you. Bye.